Okay, I think we're recording. Are we, John? I think so. Yeah, thank you everyone for joining tonight. Reinhardt's going to be speaking to us about how he automates his event-driven data lake or warehouse ingestion solution. We can ask him questions during the presentation or at the end. At the end, there will be time for a Q&A, and in this time, when we do the Q&A, I'll share a link to a short survey which you can fill in to win some AWS credits. And I think that's it really. Let's keep it interactive. Use the chat if you have a question. Just raise your hand. And we upload these to our YouTube channel at the end. So probably tomorrow it will be up. I think then that's it. Reinhardt, you can tell us a bit about yourself and take it away. Thanks.
Perfect. Thank you, Rian. Hi, everyone. First off, thank you for being here. I know we've all had a long day. It is 7 p.m. We're all tired. So I really appreciate you staying for this talk. So today we're going to be talking about how you can automate your event-driven data lake / warehouse ingestion. So kind of like a hybrid solution. But before we get into the talk, maybe just a brief background. So my name's Reinhardt. I started my career at AWS, where I worked in one of their data teams for just under 4 years. And then I realized I really hate managing resources such as EC2 instances or any type of clusters. And so I was on the job hunt for something less managerial in terms of resources. And so I found my current company, Aleios, which we're a serverless consultancy. And I'm lucky enough to be a cloud architect there, where I help clients design solutions, and then my team and I implement those solutions. So with that said, just to cover what we're going to be talking about today, so we're going to be covering a few basics around data lakes, data warehouses, what the problems are with data, stuff like that. Like I said, the problem around how we process it, then a potential solution to the problem, not a perfect solution. It might not even be a solution, but it works quite a lot of times, right? And then I did say automate the event-driven architect, or it's an event-driven architecture that's automated. So we'll talk about how we automate the solution, followed by addressing scaling issues, because in any cloud environment, when you're working with enterprise clients, you might have to process millions, if not billions, of requests either in a month or even in a day. And then that will be followed by a demo just to show you how it works from start to end, right? So with that said, first things first, we need to talk about what the difference is between data lakes versus data warehouses. And I mean, the image is pretty clear that in a data lake, what you can think of is just this a single location where you get all types of data, right? It could be multimedia data, text-based data, binary data, but the main thing around it is it's not really structured in any way. It's just sitting there, and so pretty much useless, right? Whereas a data warehouse is a lot cleaner. It's structured. You have an idea of where to find what you're looking for. It's not necessarily yet usable in the way you want it, but it's a lot easier to start working with. So that's kind of just at a high level the difference between the two. Nothing major. So sorry, I'm not sure. The slide move? It didn't, right? No, it did.
Yes, it did.
There we go. Wait, we are seeing the case study slide. Sorry.
Yes,
I
case
double-clicked and
2
nothing
though.
happened.
We see
Yes.
case 2.
Sorry, that was a type error. Before we get started, I found this really interesting case study, which I thought would be funny to share. And it's the beer and diapers case study. It's a pretty old case study. It was done back in the 90s by an American retailer. And I mean, you can read it there, but basically what they found out was that there was a demographic, which at the time were young American males who would generally after work go and buy diapers for their babies, but then also occasionally buy beer, right? And what this then boiled down to, with a bunch of very smart people analyzing the data, is they realized that there is the potential to sell more of both if they were just to place these closer to one another, right? And it actually worked. I don't have the exact figures, but I promise you, if you just Google search the beer and diaper case study, you will find a lot of information on it. It's a pretty interesting read. So that's just something interesting. So the actual problem, right? In today's world, data is captured literally everywhere. It's on our phones, your machines. Anytime you sign up for anything, there are T's and C's about the data collection, all of that, right? I mean, we have fancy fridges that do the exact same thing. But the question is, why are these companies capturing all this data? Like the case study example, that would make sense. But cool, we capture this data, and then we chuck it into a data lake, and it's pretty useless. So we can't really do anything with it, right? We have all these different kinds of data. Imagine the types of data your phone captures: geolocation, time of when you took pictures, I don't know, your favorite color, I don't know, any type of data, but we still need to do something with it, right? And so up until that point where we've actually started structuring the data, it's pretty useless. And so the current approach to this is something similar to this. We have the data in our data lake, database, whatever. We then look at the data and we try and figure out the schema of it. And the reason we want to try and figure out the schema is so that we can find valuable information within the data so that we can run analysis on it and make predictions or move diapers and beer closer to one another, right? And so how we currently do this, and I'm not saying everyone, some people have probably found smarter ways to do this, but a really good or a really commonly used approach would be to write a script to extract the data after we figured out the schema, transform it into what we want. So that could be either removing data or doing some calculations with any numeral data. And then finally, we load it into its target database, right? Once that is done, we rinse and repeat this for different data sources. But now, a few months go by, we release a new product, we want to capture additional data on what we already captured, and now our script no longer works. So what do? We go through the exact same process of we're looking at the data, we then figure out the schema, we write the script, transform it, we load it, and we do this repetitively over months, if not years. Not ideal, right? Exactly. So basically what it is, it's an absolute pain. I will have to mention that sometimes this is the only way to do it, right? I've worked with clients where they have quite strict policies and governance, and they have very set processes in place that only allow you to do it this way because they don't want to infer anything. They don't want to, they're very particular about the way they capture and use their data. And so this could be your only way to do it, and that's fine. But there are problems associated with this. And so next we can look at these problems. And I think as you've gathered, it can be quite time consuming to determine the schemas. Imagine you're looking at click data on everything in a browser. I mean, you can have hundreds of fields to look through, right? You probably only want 10 to 20 of those fields, but you first need to filter through it, find the data you want, and then write the script to do it. So what that leads to are long update windows or refactor windows when you're updating the data you're capturing. And so another problem with this is generally you have to do this for every single type of data source because the schemas of the data you're capturing are different across all these sources. To me, that just sounds like a waste of time, right? So is there any way we could potentially improve this solution or this problem, this process? And I'd like to think so. And I mean, the title of this talk does mention that it is potentially possible, right? And so I will be honest, there is no silver bullet for this. It won't work for every single thing. Um, Types of data are just too different to be able to place it in a basket and process it the same way. But it is pretty good at a lot of types of data. And in the most cases, we try and capture text data because we can do analysis on that. We're not talking about ChatGPT level analysis on images and stuff like that, right? So we can move on to the architecture. And the architecture here is pretty simple. We start with a producer. It's not going to be in this slide because the producers can be anything from a web entity, an on-prem server, anything. But the key point in our architecture, or the entry point into the solution of this architecture, is what we call Eventbridge. Now, Eventbridge is an AWS service that basically receives events from different sources that could be in AWS, could be outside AWS, and then just forwards them based on rules to different locations. And so in our case, this location would be Kinesis Firehose. Kinesis Firehose is I would say, streaming technology, but also not really, because when you think of streaming, you think real time. Kinesis Firehose is kind of hybrid where it's near real time, depending on how you modify the settings. But what it does allow us to do is send massive amounts of data without worrying what type of data it is from Eventbridge to Kinesis. Why do we choose Kinesis? Well, it allows us to do a few things, and if we wanted to already convert the data, we could do that. So Kinesis gives you the opportunity to add a Lambda, where you can transform your data while in transit, do minor transformations. Something that's generally done is like flattening very nested JSON. Or you could do real transformations where you change the data format into something like a Parquet format, which is a much more performant format. But the problem with that is you need to know the schema of the data, right? And the entire idea of this is we don't really want to know what the schema is up until a certain point, and we don't really want to care about it. So that said, in this architecture, Kinesis Firehose takes the JSON and just forwards it straight to S3. Why S3? Well, it's cheap, it can store many different types of data, and is a pretty well integrated service within AWS, and so allows us a lot of flexibility in what we want to do. So also Kinesis doesn't need any additional integrations to talk to S3. It has a native integration within the AWS, which makes it really nice. And so at this point, really, with these three services, essentially you could have a data lake, right? The data is not structured. We've just placed it in a certain location, and all that with three services. And you never have to touch anything again once this is set up. But I did mention warehouses, so we're going to extend the architecture a bit more and start structuring the data. Before I move on to the warehouse part of it, do we have any questions? Okay, I'll take silence as a no. Cool. So when we're done with putting the data in S3, like I said, in data lake, it's still pretty useless. We would need to do transformations on it to get it structured, filter it out, all of those things. And so for that, we use Lambda. Now you might think Lambda is not great at processing data, and you're 100% correct. The sole purpose of this Lambda is just to trigger the next part, which is a Glue job. A Glue job is an amazing thing to do. It takes all the headache away from a service like EMR, which is managed Hadoop, and just focuses on a very cool aspect of it, which is Spark, which is an in-memory processing engine. And so just to reiterate, Lambda is triggered by S3 at the moment a file is uploaded into S3. And so it can start the Glue job. The Glue job then itself takes the data in the format it's currently in, which is JSON, filters if you wanted to filter, but reads it into a data frame. And then literally all it does is writes it back to S3 in a better format. Excuse me. So we've now gotten from a very not relatively inefficient format for searching or querying data to a really performant format, which is Parquet, and we've placed it back in S3. Of course, you don't have to place it, and I suggest you don't place it back into the exact same bucket. It's always good to keep your data lake and your structured data apart from one another, but you could really do this with intelligent prefixing. But again, we can't really do anything with this data at this point, right? We have it, it's in a better format, slightly more structured, but we still can't query it, right? And so that is where my favorite technology in AWS comes into play, and this is called Glue crawlers. If you do not know what a Glue crawler is, it's part of the Glue suite, if you can call it that. It's this very small, relatively inexpensive technology that you point it at a data location. Initially, it only supported S3, but it supports DynamoDB, RDS, and I think they've added the ability to do custom connections. I'm not too sure about that, but you point it at a location, and then it starts inferring the schema of your data, right? And so there we've solved the time-consuming problem of having to take a sample of the file, figure it out, and then write the script to transform it, right? We've already transformed it by using a data frame or a dynamic frame that just very generically puts it into a tabular format and places back in S3. Glue crawler scans the data, sees that, cool, it's this type of data, this is the structure, and then what the crawler does is it creates a Glue table, which is just a logical table within the catalog, and then that later on allows us to query the data in Athena, and then after that, it allows us to connect it to BI tools like Tableau or Amazon's QuickSight, or I don't know what the other ones really are. Don't think it works. I don't know if it works with Azure, but there's quite a few of them. And that's basically the architecture, right? Super simple. Seems too good to be true. It's not perfect. It doesn't work for everything, but it works relatively well. It's really easy to implement, and let's just go over some of the good and bad parts of this architecture, because it's never perfect, right? It can always be improved. So pros and cons of the architecture. Like I said, it's easy to use because it's just setting up a few resources and connecting all of them. So in terms of development, the less services you have interacting with each other, the smaller the architecture, the easier it is to develop, the faster it's to develop, right? Performance, pretty good. And the reason for that is, I mean, Lambda can scale really quickly, really well. S3 doesn't care how much data you put in it. Kinesis Firehose was made for tons of data. And Eventbridge or Event Bus can be split into multiple buses if you'd like, right? Glue itself has the ability to scale to quite a large number of workers. And if you are continuously processing not massive amounts of data, like hundreds or thousands of gigabytes of data, it can still be relatively quick. It can always be improved, right? But that moves us on to it's event-driven. The moment this is set up, when the source produces data, it triggers everything else, right? There's no manual intervention required from our side, which I think just makes life easier because I don't have to worry about it. It's reusable. And what I mean by this is you can associate a different event bus. It doesn't matter. because we don't care about what the data actually looks like until it hits Glue. The crawler can immediately pick up on data changes, and it will create a different table for you, so your data doesn't necessarily even have to be that very well split. Glue has the ability to read wide varieties of data, really good with like standard CV, CSV or JSON data, ORC, Parquet, and Avro. So that's really great. So the next is that it's modifiable. If you know that you are going to only be processing a certain type of data, you can optimize your script. You can make it real time. So you can switch out Kinesis Firehose for something like Kinesis Analytics, which gives you the ability to see some metrics around the data happening and run basic queries. And then my favorite, it's serverless-ish, not 100% serverless or true serverless. And the reason for that is Kinesis Firehose doesn't scale to 0. Once that is provisioned, you're paying for it, right? If the stream is active, actually, I think it does scale to 0. Sorry, I might have to check on that.
Reinhardt, so yeah, it does scale to 0. Like if there's nothing going in, you don't pay for anything.
True. Fair.
I love it.
My apologies for that. So it is serverless, right? Cons. Like I said, it doesn't work for everything. It might work for 80% of your data, but that means you only have to do the manual work for 20% of it, right? It might only work for 50% of your data. It depends on the type of data you have, but in general, if you're processing text-based data, it's fairly good at it. And it might require minor tweaks, and that comes in with the Kinesis Firehose part with it, where you can add an additional Lambda to Kinesis to almost transform the data. I mentioned that you can flatten like the JSON data, and so you can kind of solve a few problems there. Another problem with this is you need some knowledge of Spark, which is the technology used by Glue. But it's been made easier over the past few years with the addition of PySpark. And if you have any experience with something like Pandas, it's pretty easy to move towards Spark. There is unfortunately high coupling. I mean, if one of the parts fail, for example, if Eventbus is down or the Glue service is down, your entire pipeline is broken, right? So not ideal in that. So a single point of failure, if any part of that fails, it's broken. So again, like I said, not perfect, right? But how reusable is it actually? And I have touched on this, and I'll just clarify again. It can be used for different types of data. We can even extend it past Eventbus, right? You can have your own producer directly writing to Kinesis Firehose. You don't actually have to go through Eventbus. I just use that as an example. The Glue script automatically adjusts. If you're reading in standard types of data, the data frame can pick this up because it dynamically figures out what the schema is, right? I don't know, the people at Spark and the people in Pandas were really smart when they did this, and I thank them for it every day. The Glue crawler picks up on data changes. As I mentioned, if let's say you connect 4 different event buses to it, all sending widely different types of data to the exact same S3 location, that data is then processed by Glue and stored. When the Glue crawler scans the data, it can infer that there are differences in the schemas, and with the correct crawler settings, and it's a simple tick box, it will allow you to create different tables for different schemas, which is really nice. Again, not a foolproof plan, right? But it gives you a good idea or a good starting point. So still seems pretty manual, right? I talked about automating this, but as it stands, you'd have to go into the console, set up everything, connect everything, test it, have some errors, rerun a few things, and hopefully get it working. So this is the exact problem we're trying to solve. So how do we solve it? Well, we could package it. And no, I'm not talking about like an npm package or a pip package or something like that. That could be cool though. I think there's someone smart enough out there to figure that out. Myself, I'll just go for good old infrastructure as code, right? When talking about infrastructure as code, this is not an exhaustive list by any means. But if you're talking AWS, you've probably heard of all three of these, right? And so I thought I'd mention them. CloudFormation, probably, in my opinion, not the best. If you've ever tried writing any CloudFormation template, it's a pain. YAML is a pain. It's error prone because you've spaced something wrong, anything like that. They do allow for JSON, which makes it slightly easier, but then you have this very long file you need to keep track of where you've referenced what. And so not ideal, takes a lot of time. And then if you're doing this for multiple sources, you probably require multiple copies of it, right? Then, of course, you have Terraform, one of the very big names in IAC. Multi-cloud, I think that is amazing. So truly IAC, because with it, you can, I mean, you can have 10 different environments in all three major cloud providers, and if managed correctly, deploy that in a single go. You have to be good at that because it's not the exact same for all of them, but you could do it. Personal opinion still is it is tedious. I have found when I work with Terraform, you have to write quite a lot, an example of resource blocks and all of that, and I feel it could be cut down, right? But saving grace is it uses the CLI under the hood, at least for AWS, which makes deployments really, really quick. And then you have CDK, like it says, it's made by AWS for AWS, not multi-cloud. The thing I like about it, though, is the familiar environment for devs. It's something that if you've developed quite a bit in your life, or you studied computer science or whatever, you will be familiar with some of the concepts used in there, such as the approach it takes to object-oriented development, right? Has a very high level of abstraction, and so you can get away with minimal code if you really want to. I think there is a problem in my slide with the CI/CD. I think it's cut off, but it's meant to say it's quite slow, right? If any of you've ever developed a stack with 50 plus resources, it's going to take quite some time to deploy that. And then maybe only it errors out at the end, and so you've wasted a good 15 minutes sitting there. But it does make testing easy, and it does support multiple languages such as Python, C#, Go, I think Java, and I know TypeScript, right? So I would say pros to CDK and Terraform. I don't like CloudFormation. Again, personal opinion, I might be wrong. So if you've never heard of the CDK, I'll just give a really brief overview of what it is. The two main parts to the CDK, and that is stacks and constructs. And basically a construct is just where you declare and define some of the resources you want to create. They have different levels of abstraction, going from L1, which is the lowest level, and basically just CloudFormation in a different format, to L3 constructs, which is generally the ones you create custom. The most used ones would be the L2 constructs. There's a lot of them provided by AWS. If you were to Google CDK reference, you will find hundreds of constructs there with really good documentation on how to implement them. And so the idea is you build up these constructs, and then you create a stack where you initialize all these constructs for all the resources you want created. And then that stack you synthesize, which physically creates a CloudFormation template. And when you click deploy, it uploads it to CloudFormation and then deploys it through CloudFormation. So that's basically what the CDK is. And I know I've talked a lot. And so I'll show you a slight bit of code. I don't want to go too much into it. But what we can see here is it might seem overwhelming. Don't worry, it seems like the first 15 lines are just imports. This stack here, or this construct here, is actually one of the data lake constructs. And so what you can see, if you look kind of to the bottom left of the screen, you'll see there's the Kinesis processor. So in this case, we do flatten JSON. There's the S3 event trigger, some additional information about log groups, because logging is important when trying to debug or just find issues, a role, and then create the Firehose event targets. And then the two main things there is the Python glue job and the glue crawler, which is what I spoke about earlier, right? So we've now talked about how we automate it, right? We do it through the CDK, we package it. Now we've talked about the actual problem, but the one thing we haven't touched on is scale. And I think when you develop in the cloud, one thing that is a major advantage of the cloud is it allows you to scale almost infinitely, right? But you also need to think about that when you develop, because not all architectures work at all scales. And so the question is, does the current architecture we created, that very simple architecture, does that work at any scale? Does it work for every use case? What about real time, right? I mentioned it, I think I already gave the answer that it doesn't work for real time. But how do we modify it to do that, right? And then, of course, what are some of the potential implications when we do modify it for scale? So in the next slide, what I'm going to show you is, and it's titled a scaled up version, but I would also reference to it as a more real world example of what you'd likely see in something like this. And I'll just quickly step through it. On the left-hand side, you have the producers. Like I said, it won't just work with Eventbridge. You can do it with on-prem, Greengrass, IoT, bunch of external services. We still push it through to Kinesis Firehose, and at some point, likely, I don't know at what scale, but you might need more than one Firehose stream. And then we follow the exact same process of where we send it to, I would say, the intermediary storage location, which could be S3, Redshift, Dynamo, EMR, or RDS. You will see that there are Lambdas in front of the last three services. And the reason for this is not all of them have native integrations with Kinesis. And so you just need a Lambda to help you with that. You can then go to Glue, do the exact same thing, the transformations, all of that, push it through to all of the targets. EMR is not there. And the reason for that is generally when data enters EMR, it doesn't leave EMR because Glue is just Spark, and EMR already has Spark, so there's no reason to send it back to Spark if you can do it on that cluster. And then again, you can connect it to Athena, which you can connect to QuickSight. And then if you want a nice, full, proper data lake / warehouse, you can add an additional layer of governance with lake formation, which is just additional permissions on above IAM. So it supersedes IAM permissions in certain cases. And the reason for that is you might just want to lock down some data to certain people within the company. So I've done quite a lot of talking. I'm always a fan of seeing something work. And so with that, I'm going to move on to the demo. And so please, if you can tell me if the screen switches, what do you see? Do you see the AWS console?
Yes.
Fantastic. So while speaking through this, we're going to look at S3. This is the bucket that I'm using. As you can see, there's nothing in there.
Reinhardt, sorry.
Yes.
Can you maybe just zoom once or twice for some
Sorry
people?
for that.
Yeah, that's
Is that better?
Thanks.
So if we just quickly go to this architecture, Eventbridge is I can show you the event bus, but it's a very basic event bus that just forwards events to Kinesis, which is going to forward it to S3, right? So we have Kinesis set up. S3 is here, Glue is here, but as you can see, there's nothing in S3, right? And so what I'm quickly going to do is I'm just going to run a script that just produces 50 events in event bus. While that is currently running, if I just wait for that to finish, hopefully it is all available in S3. So if we do a refresh, we see that we've got input data for 2024 in the third month on the 26th. 1700. Oh, this is in UTC format. So remember, there might be some, well, it's changed here. So we can see it at pretty much a minute ago, right? But it's still not automated if we don't see it running here. And so if we refresh this, we can see that our Glue script is running. While this is running, I might step you through the script just to exactly show you how really basic it is. Again, don't worry about any of this. When you create a Glue script, this is standard.
Reinhardt, sorry. Like you're gonna have to zoom, a few more times if you want to show us
Sorry,
that.
I forget this. My bad. I'll try to remember.
No worries.
So as mentioned, this is just very basic. This is all included in any Glue script when you create a new one. So don't worry about that. What I did here is I just added partitions. This isn't required. But when you're processing a lot of data and you're querying it, you don't necessarily want to search over the entire data set because that's just going to cost more money and also going to take longer to query. So preferably you want to be able to target specific timeframes. From here, what we do is we read from S3. So our input location would probably be, well, not probably, it is our auto pipeline. As you can see, the input data here. And then from there, we specify that it is JSON data because currently it is. And then we convert it. In this line, I'm not a fan of this, but this works and makes it more flexible. Basically, it just turns everything into a string. Not always necessary, but it will allow to work with more data types for some reason. There's nothing stopping you from casting it back when you're using it downstream. And then again, like I said, we outputting it in a partition format, and this is just how we output it into S3. So hopefully this should be done, right? Great, it didn't fail. And so if we move back to S3, additionally, forgive the naming, I just called it Parquet. But what we should see is some new data in here, right? Not ideal file sizes, but we do have our Parquet data. So one thing I didn't mention about the crawler, because that is the next step, is you would generally run this on a cron. And the reason for that is you don't need to scan all the data. Once you do have the schema of it, that schema is in this Glue catalog. Where is the, well, in the Glue catalog. Currently, no tables because we haven't done it. But for the purposes of this demo, I'm going to run it on demand. Another thing about why you only want to run it once a day is because we partition data by day, we only want to be able to add that partition once that day exists. And so a time frame like, depending on your traffic, you could send it like 2 a.m. or 3 a.m. Or if you only need it at 6 a.m., run it at 5 a.m. And what that would do is it would create a partition within your S3 bucket. So this is going to take around about a minute to run. And then essentially what we would like to see here is, as you can see, we don't have any data yet, right? But if all works, all we need to do is give it a simple refresh, and hopefully we have a table here that is partitioned, that's correctly picked up the schema, and we can query it. It's probably not going to be very useful data because I didn't apply any filtering. So I think it's going to just send through the entire event. But we'll just have to wait for this. It should be done fairly quickly. So it's stopping. I don't see table changes, which is not ideal, but hopefully, please. Live demo is always a risk, right? Ideally, we should see a table. The default, it's not default. Well, we'll just wait until it's finished. In the meantime,
I've never had a good experience with the glue crawlers.
They could be quite finicky when you do work with them. Yes, that is true. I tested this earlier this afternoon and it worked twice. So I guess third time's not the charm. But I mean, I guess that's how life works, right? It's generally when you want to try and show someone something that it doesn't always work.
And if
We'll
you
just
click
see.
on it,
Yeah, let's just see. You see
wait, what's
no changes. Every single time I did it, it worked. But it didn't work. So that's not great. So maybe if I run it again, we can hope, right? Unless I changed something. Let's just quickly check. That's there. That's perfect. That works. Anyway, in an ideal world, we would have seen a table. I am sorry that the demo didn't go as planned. I really wanted to show you this. But if we look at recent queries, I can no, you see I've dropped it. Well, you can't drop the table again, but I can potentially see the results from query. This is what we ideally want to see, right? So this is the event bus. This was created a bit earlier this morning, but as you can see, it is in the exact correct partitions. So that is the demo. Not great, but that does bring us to the end of the story. So first off, again, thank you for listening. I'm sorry I went slightly over time. If it worked, I wouldn't have. But yeah, I think that's it.
Yeah, I think your time was good. Thanks for that. But luckily we could see the results from the previous queries. That saved us.
Yeah, at least, right? Better than nothing.
Does anybody have any questions? I dropped a link there in the chat. That's the entry for our AWS credit lucky draw that we'll do in a few minutes. Do fill that out, and then we will choose someone after the Q&A. But for now, if anyone has questions, I see there's been a few questions. Let's just go down the line. First one was, could you also do this with the Glue visual editor? So I guess that's the Glue jobs, or
so Glue has the these Glue visual ETL. You could do, I think, parts of it. So if we look here, I mean, you could select the. You have to excuse me. I never use the visual part of it. But this is actually a good thing to show you. Here you can see all the sources that you could use for your Glue job, right? So I mean, so you could use Google BigQuery, a lot of Azure, and then you could also do connections. In terms of transforms, you could, I think, again, you need to know the schema, and that's why I went for a data frame and not a dynamic frame, because the data frame has the ability to pick it up dynamically. but I guess you could probably do around 50% of the work in this and then just do some modifications to the script. Okay. I would still just suggest do it the old way. It just gives you a lot more flexibility in what you can do with it. Again, I don't have experience with the visual part of Glue. I just don't use it. I prefer the old scripting way of doing it. Yeah, sorry. Sorry, I couldn't really answer your question.
And the next one is where does the glue crawler send data to?
Okay, so the Glue crawler doesn't actually send any physical data anywhere. Where the Glue crawler does do something, and again, if our table did create, I could have shown you this. But basically, it sends metadata around the data to this. And so maybe to this catalog. So maybe if I just show you, let's do a test, I'll choose this database, description, whatever, S3, include path. Let's just browse S3 quickly. Let's just do this. No, that's the wrong one. Oh, no, that is the correct one. If we do this, sorry, I have to now go through all of this. This one, why can't I choose this? I can, there we go. So if you were to choose that, of course, we say whatever the format is, valid. What's wrong with this? Object, oh, we need the object of it. I just want to show you what the data will actually look like. But it's basically just metadata around the schema of this file. Again, why is it? There we go. You can't. Okay, that's not working. Apparently nothing's working today. We'll call it schema example. I will zoom in. Could potentially be this. Don't see anything. Oh wait, this could be easy. What it creates is this. I will zoom in again. It's not the wrong one. DDL statements. Let's just search one. Let's just search a CloudFormation one. And of course, when I look for an example, I won't be able to find one. Let's see, images, potentially. So it would create some things. No, that's the wrong one. But it creates, yeah. So if I can just do this, so that's not what we wanted. Let's just copy that, do this, paste it here, if it will paste. Nope. It creates this table statement. Why won't it paste? Okay, I can't show you. Nothing's working today. I fumbled. I'm sorry. But it defines the schema for the table. That's really all it does.
Okay. And then Louise, you raised your hand for a second. No, I said no problem, so I got it. Okay, so I'm going to move on to the next one. May you explain again how we would filter out the data in the S3 warehouse? Would this be on object? Would this be on object an object level, or it allows for granular filtering like certain objects in JSON? S3 select like. Do you have an
Uh,
idea about that?
let me just quickly read that question. Let me just open the chat.
Okay.
Oh, yes. So in Glue, you have something called a transformation CTX, which is just a fancy way of once you have the schema, you can do a df.show, which shows the schema. And then you can either, well, data frames are immutable. So what you can do from that is you can select certain fields from that data frame and insert it into a new data frame, and then write that data frame to the location you want to instead of all of the data. I think that's what you mean. I'm not sure. But that's how you could filter out data.
Do you see the next question? It says, I was wondering how the pricing looks for a solution like this, on a small scale and on a production scale.
Yeah. So I mean that's always a difficult question to answer. Maybe the dev side is a lot easier to answer. If you're working with a small data set like this, your Lambda invocations are going to be next to nothing if not free, because there's a certain free tier number of invocations and compute time. S3 you always pay for storage, but it's pretty much nothing in the bigger scheme of things. Your main cost is likely going to be Glue, and the reason for that is if you go to Glue, and I'll just use this one for example. What you'll see here in the details is this worker is their least powerful worker. And so you can go to G.8x worker, and then you can also choose a number of workers for this. And I can't remember what the exact billing time is, but I think it's 10 minutes. I'm speaking under correction. And so even if you run a job for 2 minutes, you're still paying for that 10 minutes, right? I can't remember what the exact time frame is in terms of billing, but it can get quite expensive. And so what you can do is you can invest a lot of time in optimizing the Glue script itself. If, for example, I don't need this dynamic frame. I can read into the data frame immediately from S3, which at this scale doesn't really make a difference. But if you're talking about gigabytes, and I mean hundreds of gigabytes, converting from a dynamic frame to a data frame is a very memory heavy process. And so that takes a lot of time. All your executors will be busy trying to do that. And so your job will become slower and slower and slower. And then again, converting it back to a dynamic frame just so that I could easily write out how you would do this was again that exact same memory expensive operation, just in reverse, right? So you could cut that out and just keep it to either the dynamic frame or just the data frame, and you could at scale almost half the execution time, which of course halves the cost. So I would spend the most time in trying to optimize the script as much as possible. In terms of an actual dollar amount, I can't tell you, because production for one company is 1,000 entries a day. For another company, it's 10 million, right? So it's a very difficult question to answer. I'm sorry.
Thanks. That was good. I actually also have one question. So you converted everything to strings, and is like all of the data columns then strings when when your glue crawler is finished, or does it convert it back into what it thinks that data field is?
So the glue crawler will read what the Parquet data specifies it is, right? So Parquet files have a section in there that is solely dedicated to metadata of the file, and it tells you what the format is of the column and also the starting and end location of that column. And so it will read it as a string. When I mentioned casting, I was specifically talking towards, for example, in Athena, you can cast it. With Athena, you can also, create, it's called a CTAS query. So you can select data and write it out to a different table. But there's nothing stopping you from just keeping it as the format it is in JSON, right? If it's a string, it's a string. It can handle numbers. Like there's a lot of data types Athena can handle, and that Glue script will be able to handle it. It's just in terms of simplicity, having everything as a string makes it a lot easier to work with. Unless you have very specific values that require additions, there's no need to do it, right?
Okay, so then everything in your Athena table is going to be string columns, but then you can transform that and use it if you want to.
Correct.
Is that
Yes.
what it boils down to?
There's absolutely nothing stopping you from converting, for example, the account. Let's not think this was an account number. Let's say that was my bank balance. That would be an amazing. But let's say you wanted to do additions or modifications or anything like that with it. You can simply cast it as an integer or as a double, depending on what you require, and then just continue working with it as is.
Okay, that makes sense. Let's see, no more questions. We are almost out of time. Look, just like maybe one more. The code that you showed, is it maybe available somewhere, or is it just something you threw together quickly?
This is just something I threw together quickly, but I'm happy to share it. It's pretty standard. There's nothing special about it. So yeah, it's very easily shareable. If you want it as an example or anything, I can just send it to you. Or I don't know where the best place is to share it.
We can share it on the event itself, like in the chat. But otherwise, it's fine. I was just wondering.
Okay.
Not too important.
While you do the closing statements and the lucky draw or whatever, I'll quickly get this file and upload it to the chat so that it is shareable.
Okay, but no rush. I'm gonna share my screen. Choose the right one. There's guys out. Can you see my screen? I'm only seeing myself. Someone just give me a thumbs up. Yes, okay. Need to refresh over here. Be grabbing the names of the people who filled in the survey. Paste here. Now we click on spin. And that's our lucky winner. I am really sorry, but I won't be able to pronounce your name. If you want to, you can unmute yourself and just help us with that pronunciation. But I will send you your credits via email after the meetup. I think it's a 50 credit or something. I'll just double check. Thank you very much for putting in that survey.
Okay, cool.
I
Thanks.
see there's one more. Like, what's your name? Can you give us it?
Steve Yile. They just call me Sibu.
Really. Okay.
Yeah.
Cool. I see there's one more question that came in from a storage perspective. Reinhardt, are you still listening?
Yep.
Like from a storage perspective, it would be better to store the data using the correct data types. Parquet can optimize how it stores it, ints versus a string, deterministic, and date times. Yeah, that makes sense.
Yes, so you are 100% correct. That is the ideal way to do it. I agree. This was by no means the best Glue script I've ever written. I was just to serve as an example. With that said, I also did share the Glue script. Please feel free to improve on it. Yeah.
Cool. I'll be sure to send it in the chat and maybe also on the social media post. I'll just attach something, just like something like that. And I think that brings us to a close. That's it. Thank you everyone for coming. Reinhardt, if there's anything else you want to say, there is something I want to mention. Please find us on YouTube or on Twitter. The links are over here. And also on Meetup. There is a new Meetup scheduled for 6 in April. It's about CDK, SST, and moving from serverless framework to the CDK. It's from Amu. He talked before in this group. He's working at a company that does logistics, I think, of trucks and moving stuff around. It's very interesting. He's a great speaker, so please join that one as well if you enjoy the serverless stuff. And just find it on the Meetup page. And then that's it. Thanks for coming, everyone. I'll send you those credits, and see you on the next one. Thanks, Reinhardt. Great presentation.
Thank you, everyone.